So with no further ado, a word about myself. So I'm a software engineer, have been doing it for 20 plus years, and I think I'm still learning on the job, and I expect to be doing this until the day I retire. I've worked for a significant chunk of these 20 years for Checkpoint Software Technologies, dealing with traditional network security, remote access solutions, delivering them to leading enterprises worldwide. And that's what sort of sparked my interest in zero trust models, entitlement management, et cetera, et cetera. Now I'm a chief technology officer of a startup called Luminate Security. We use a lot of HashiCorp open source solutions in our development pipeline. Our startup has recently been acquired by Symantec. What I'll be talking to you about today is not about what we do, but actually about how we do it. And this is a very important part. So I will do a short introduction into what is zero trust, and then even more specifically into what it means to implement a zero trust access or a software-defined perimeter policy in your organization. I will maybe outline the differences between the two. I will advocate our opinion on why zero trust is a particularly good idea when you're running any kind of software and infrastructure as a service, software-defined data centers. I will show a couple of actual examples from our internal challenges and how we resolve them with zero trust. And then we will reach the very point of this conversation, and it is how to connect it to infrastructure as a code. What are benefits of connecting it to infrastructure as code? And then, of course, I will sum up, suggest some follow-ups to those interested, etc. So zero trust. Although we don't have a question, time for a quick show of hands, but I think in terms of Google Trends, this is one of the more trendy notions in IT security for the past year and a half. It's a model, in case of zero trust, it's a theoretical security model that is based on the idea of we never trust anything or anyone, but for every action, we continuously verify whether it is making sense or not. Let me give you a very simple example. So for many years, when I've been coming to work, I would take my laptop off my bag, I would plug it into the socket in the wall, and suddenly I'd get access to various network resources that were available on our LAN. That meant trusting. My laptop was trusted just before I was in that network. Alternatively, I could have been remote, working from home, and I could have connected to my corporate data center with a VPN client. I would authenticate myself, maybe using just a password. Maybe we would have strong authentication. And then after I did that, again, I would get a full access to certain subnets, certain data centers, again, because I was considered trusted after I have completed my authentication. This method negates all of these notions. It was pioneered back in the days by John Kindervag, who's today field CTO at Palo Alto Networks. Back then, he was a principal analyst for Forrester Research. He has compiled a lot of challenges that the IT security industry was facing for decades up until that point, and came up with a theoretical solution. His approach has since, and it's been almost a decade, developed into a number of applied directions. So things that many of you, I guess, are familiar with, things like micro-segmentation of your data center networks, software-defined perimeter, continuous frameworks such as zero trust extended or continuous adaptive threat and risk assessment. All of them are actually based on the very principles coined and pioneered by John these years ago. So let's explain what is zero trust access by creating a sort of negation between that one and a traditional access. Let's look at a very simple use case. Let us say that I'm a software engineer. It's easy for me to imagine that part. And I have operations, the service that I'm operating, it is deployed partly in my on-premises data center where I use OpenStack, and partly in my Amazon Web Services VPCs spread around a couple of regions. So if I was dealing with traditional access, and I would need to access the databases, virtual machines, file storages, whatever I have in any of these locations. I would be talking about getting myself somehow to access these resources based on IP routing. So from my laptop, maybe from my mobile device, I would have an IP routing all the way into those networks. I'd be opening TCP sockets when connecting to various resources. This is the traditional access. In the world of software-defined perimeter, I never get network access. I can only access certain applications, resources, or workloads by passing through a layer 7 proxy. And it would be a good idea, we'll talk about that notion, that the proxy itself is located completely outside of my data center. If we think about this alone, right, let's say we managed to create 100% access to our infrastructure via proxies, that would have a tremendous positive impact on the attack surface of our infrastructure, right? Not a single packet will ever be generated by a TCP stack on my laptop that should be considered untrusted by the system and would travel all the way through encrypted tunnels, public network, doesn't really matter, into the data center. So that's difference number one. If you think of it, the biggest inspiration for this difference is the ability of many software as a service vendors today to provide very complex applications, things going up to, I'm not talking about continuous integration in the cloud. I'm not talking about IDEs in the cloud, all of that. And you can use all that, and yet you never actually VPN into the network of that vendor. So our notion is that the solutions that we develop ourselves should not be different from that. Point number two, when you get a traditional access, let's say I got access to my data center network, and now I would like to SSH into one of the virtual machines. Or, maybe I have a database running there, and I'd like to connect to it with my SQL workbench. The paradigm is I first create a TCP level connection, perform a TLS handshake depending on the protocol, right? And only then I authenticate using the means that the application or resource supports, after which I start working. But if you come to think of it, there is a fundamental flaw here, right? Because if I can connect to various resources before I'm actually authenticated, it allows me to scan the networks that I get access to with regards to what kind of other resources are there. It allows me to leverage various techniques to start maybe guessing the credentials, maybe steal credentials, etc., etc. In the world of software-defined perimeter, you can never access, you can even never know about the sheer existence of the resources you are intending to access before you have authenticated to the system. You see, it's a complete reversal of paradigm. First, something is exposed. Everyone can try and connect to it, and then undergo authentication, get assigned a certain permission profile, etc., as opposed to nobody can connect. There is no public address, no address space you could scan. Only after the authentication, you gain the ability to connect to resources. And third most fundamental difference is that in traditional access, after I have been authenticated and authorized, I gain a direct connection to whatever it is I'm working with, be it a database, file system, SSH into some Linux machine, RDP into Windows machine, etc. The ability to audit and control what I'm doing during that connection is becoming a sole responsibility of that application that I'm connecting to. The fabric that allows me to connect to the resources doesn't bear any responsibility over governing and auditing my actions, which is a fundamental principle that allows vast majority of modern network security, vulnerability exploitations, and other types of attacks to take place. In the zero trust world, as I've mentioned, even after I have been authenticated and authorized, every step I take when accessing certain applications or resources is being validated with a policy. So I may gain access to a certain, let's say, production EC2 instance in AWS, and still, if I start executing or if I try executing steps that cross the boundaries of what I am supposed to be doing, as a result of my role these will be prevented. So there's never a carte blanche. Here you go, Mr. Accessing Party, access this resource and execute whatever thing you want. So if I had to really summarize the vast difference between getting a traditional IT network access to something and getting a software-defined perimeter access to something, it would be this. In a traditional access, I just connect to the remote network. I can, using IP tools, identify various resources that are accessible there. The only segmentation that can be done here is using network firewalls on the sub-network level, etc. And even that, when we think about a scale, when we think about dynamic nature of software-defined data centers, is extremely difficult to manage. In the software-defined perimeter world, I'm not aware of a network. I have some sort of endpoint that I connect to. That endpoint may or may not reside on the same network as the actual resources. As I previously mentioned, there are benefits to it actually not residing on the same network. But the main idea remains, I have no idea what kind of resources are behind this endpoint. I have no idea how many there are, and I will never be able to even figure that out unless I get explicit authorization to access them. So this principle is called cloaking. Whatever I'm not authorized to access is completely cloaked from me. Why is it a good idea for cloud environments? I mean, at the end of the day, you could, and many organizations do implement Zero Trust today in their on-premises data center as well, but I believe that for cloud, it is particularly useful. And when I say cloud, of course, infrastructure, platform as a service providers. So first and foremost, when I create a virtual data center somewhere, by cutting any kind of inbound network access, I really make myself secure from the get-go by design without a significant investment. Think about it. I believe that many of you on this call have read about people leaving management consoles for their Kubernetes clusters, leaving Kibanas or Elastic REST APIs completely exposed to the internet, hosting virtual machines, not patching them, and then being penetrated by exploiting either TLS level vulnerabilities, constant scans that are running at the network, trying to uncover, standard services running with out-of-the-box default passwords, etc., etc. By just not allowing any inbound network access, having a single action just completely takes all of these questions off the table, which is a tremendous value by itself. Second point is the fact that the cloud environments, the data centers consisting of compute, storage, and many other resources, when it's software defined, one of the benefits we gain is that it can be duplicated either for different stages of development or for different customer environments, or even provided within different regions, and also not only duplicated but moved with complete ease, right? And when all of the access scenarios to these infrastructures are being done with Zero Trust, suddenly that duplication, move, etc., becomes much more agile because there is no dependency on your network address space. You don't need to consider network address translation for overlapping networks. There is no concern whatsoever whether you're running a single instance of this virtual environment or multiple instances. In any case, all you need to worry about is that each and every one of these instances has an identity, and the access is done without any network considerations, just based on the identity. Cloud environments tend to be, and that's a good thing, elastic and scalable. We, for instance, in Illuminate, are huge believers in the old statement that says, treat your infrastructure as cattle, not as pets. Therefore, there is no such thing as a particular machine. There's no such thing as a particular storage bucket, right? We always have many of these, and what matters is what is the logical role they play in our processes, and that, of course, is being managed by metadata tags, right? So the ability to extend your environments very easily without suddenly, any kind of a discussion on, do we need to open additional ports? Do we need to provision additional identities? Nothing of that sort is ever an issue, and that's a huge plus, right? These processes would anyway take weeks in traditional old school data centers, but in the cloud, it's minutes, and they should not be slowed down. More and more industries, verticals worldwide are introducing regulatory compliance frameworks. If you're dealing with anything related to consumer data, personally identifiable information, the chances are that either already or maybe in the nearest future, you will need to conform with various procedures that require you to be able to govern who gets access to what, audit who gets access to what, present this in a deterministic manner, and so on. It is quite difficult, and by that I'm sort of masking almost impossible, to do that if you're providing a wide network level access. Because then what you would need is you would need to hope that all logs from all of your types of resources can be collected, can be normalized, can be analyzed for forensics, and that just does not happen. Giving only proxied, uniform layer 7 access allows you to audit whatever the users are doing with your data, and that's extremely important. Being hybrid, and for many young companies, being hybrid would mean running both on, let's say, Azure and AWS, or Azure and Google Cloud, etc. For many traditional companies, being hybrid means still having investment in private clouds or data center alongside adoption of public cloud CSPs. Zero trust, being completely agnostic to network topology, location, etc., can be used to have a uniform set of security controls all over asset space, wherever they are. And of course, last but definitely not least, is when you're dealing with access that is on the application level, it is extremely easy to factor in various considerations, the time, the location, the device, the type of data you're accessing, the sensitivity of the operation you're performing, etc., etc., etc. That flexibility is a real value when you try to address various access scenarios. So let me give you a very short example based on our environment that we run and what kind of different access scenarios we have inside and we govern. So we do have a set of cloud-based environments, of course, for development, staging, and production. And we also have some sort of legacy on-premises environment where certain services are located and where they're accessed by different components in our cloud environments. First and foremost, what we have in these environments is various compute resources where our microservices are deployed. And immediately we have two very distinct access scenarios with our R&D engineers getting full high privileged access to the dev and somewhat to the staging, but getting extremely low privileged access to production environment that contains sensitive data of live customers, right? This is where we need very strict auditing, etc. We do some level of auditing on staging and dev as well. So imagine it could translate into an R&D engineer SSHing into a dev environment machine and being able to perform any kind of operation, being able to modify any piece of configuration. And then when they do exactly the same with a corporate identity, albeit to the production machine, they will only have very low privileged permissions that will allow them to retrieve logs, right? And then we have a different population, right? Our DevOps groups that will have high privileged access to all environments, but there, due to the fact that it's a high privileged access, we enforce a 4I principle for any sensitive operation, something that gets improved by the shift manager, something that gets audited for later forensic ability, and so on. So here you go. Consider the wealth of security controls and the wealth of information we extract with auditing just with these two very similar and very high-level access scenario families, things that I guess any organization that has any kind of R&D does. But it's far from being it. We also have our databases and our storage. And here come additional scenarios. So again, right, the R&D engineers, they need to have full high privileged access to development database, and then maybe slightly lower privileged access to staging databases where we really need to simulate the regular conditions. When it comes to production databases, we really do not want them to have any access, and there is a very strict approval cycle that gives very narrow access for very restricted amount of time only to specific portions of that storage, because indeed it may contain sensitive information. As opposed to data analysts, right, that do need to have access to data storages in the production environments. However, when they get access, the information they get will be tokenized, will be anonymized, will be will be numeric, but they will never be able to get access to a sort of like single user, single account, single something. And again, imagine the amount of investment we would need to implement in order to do all that based on just network connectivity. And then, of course, we also use various platform as a service offerings for analytics, for data pipeline, etc. And then again, we have different families of access scenarios. Our site reliability engineers need access to data about the operational parameters of the system, but not the ability to modify configuration of running services or access the production data. Our IT security, chief information security officers and their team needs to have access to allow them the ability to audit the security configuration, the audits, the hardening, but never to the actual information. And the business analysts, similarly to data analysts, will get only access to certain operations. There will be restrictions on the kind of information they can pull. There will be approval cycle built in. So when considering this environment, which is very typical of any organization that provides any kind of service, right, based on software, these are just the tip of the iceberg, and we implemented all of them in our environment using Zero Trust, using a very unique approach, and I think it saved us many months of work. So how is it all related to infrastructure as code, right? At the end of the day, we were talking about hardening security configuration, managing entitlements. What does it all have to do with infrastructure as code? And here it is. You see, we manage the infrastructure itself as a code. So adding an additional layer of managing entitlements, who can access various pieces of this infrastructure, under what conditions, with what governance strategies, and so on. Storing that piece just as a code as well in a separate repository. Running continuous pipeline, sort of GitOps style on top of it. Validating it by linting, by doing static analysis, by alerting when someone by mistake has opened the access to too wide an audience, for example, and so on. We can have a uniform organizational process for everything. That's how we modify the codes of our microservices, of our business logic. That's how we manage the infrastructure code that builds our infrastructure points of delivery. And that's exactly how we manage the entitlements. Now we can use all that, and now when it's a piece of code, it's really easy to create a modular structure, to replicate this thing for various instances, to create even sort of like an hierarchical structure where we have common and specific deviations for various environments. And of course, we are huge fans of doing everything automated. So this thing, its enforcement on various different environments, is also part of our automated cycle. To sum this thing up, first and foremost, we believe that Zero Trust is a very secure and an effective method of managing secure access, of saving the heartache and the trouble for a wide array of potential network attacks on your infrastructure. And it is particularly efficient in software-defined cloud environments. We believe that when you integrate it with infrastructure as code, every time you spin off a new instance of any kind of point of delivery of any kind of service, have it spinned up with a baked-in access policy, who can do what, from which devices, from which locations, under which conditions, who gets to approve deviation, who needs to alert, who needs to be alerted in what case, and so on. Building this thing together increases the power of your infrastructure as code into creating almost sort of like a business backend as code, which is what we deliver. When it comes to how we actually implemented it, there are various approaches. We tried various approaches. First and foremost, and it's a good thing, more and more cloud service providers, definitely the big ones, are offering built-in technologies that could help you leverage this thing. And of course, you can control them. We are huge fans of Terraform. So in this case, we have modules for Terraform for creating all of this. If we're talking AWS and access to web portals, you could use application load balancers and Cognito. If you're talking about governing access to SSH machines, you could use Session Manager, Systems Manager, and again, provision these resources using security groups, using Terraform modules. For REST API access, of course, the API gateways. Similar infrastructure exists at the Google Cloud Platform with the identity-aware proxy and certain tools they have recently started offering on top of their CLI, and of course the Apigee API gateway offering. And again, Terraform modules can be used to create that infrastructure as a code and then build the entitlement level on top of it. For Azure, we're definitely worth mentioning using the Azure AD application proxy for anything web-related. Unfortunately, they do not have a real zero trust access to the infrastructure, but you don't have to use only the CSP provided solution. There are also both open source or commercial dedicated offerings for creating zero trust access to your environments. So there are two big families. One family is sort of concentrating on privileged access scenarios. Again, I will not be mentioning particular products, but there are quite plenty of them. Privileged access scenarios would require SSH, database access, anything in between, access to your Kubernetes clusters, et cetera, et cetera. And also there are all-inclusive solutions. When picking a solution, it is important, first of all, to see that it comes with the ability to be fully controlled by your infrastructure as code. That's how we pick all of our IT stack, security stack, automation stack, etc. Some of these solutions actually come with a state-of-the-art integration with infrastructure as code. Others, unfortunately, were originally built as an IT tools, and they're lagging behind. So it is extremely important to choose your strategy wisely. I think we have 3 minutes remaining, so if there are any questions or anything I could help with, I'll be happy to respond. I'll be also happy to answer any follow-up questions. It's leonid@luminate.io. Zero Trust is my passion. I will be happy to share anything related to it with my colleagues.